Andrea works at the Elkhorn Slough Foundation, also near Santa Cruz, and she actually only lives a mile from my house, but we had to come up here to catch up. Andrea actually did her undergraduate at CSU Chico, and she did her master's at Moss Landing Marine Lab. Sorry, talking too fast. Jody and I kind of try to outcompete each other on that one. And she has worked since 1999 as the stewardship coordinator at the Elkhorn Slough Foundation, where she does a whole range of different types of stewardship activities that I'm sure you're all familiar with, like invasives control and restoration and things like that. And she will be talking about one of her projects today on that work. So, Andrew. Thanks, Karen. And yes, there's.
Okay. Thank you, Karen. I'm going to read this so I stay on time, so forgive me for that. So this is a story about what happens when you are asked to restore a grassland on an area essentially strip mined to create fill for a salt marsh restoration project. My co-authors and I work at the Elkhorn Slough National Estuarine Research Reserve, which is owned by the California Department of Fish and Wildlife and is located in the heart of Monterey Bay. Elkhorn Slough is one of the larger estuaries in California. So on this map, Monterey Bay is on the left, and the main channel of Elkhorn Slough is blue and runs through the middle of the map. And then you should be able to see the yellow outline of the Elkhorn Slough Reserve, which is 1,700 acres. So what I'd like to do is take a look at a central part of the estuary from the area, which is located in the red circle that I've put there. So like many estuaries, Elkhorn Slough has lost a lot of its salt marsh. First, the loss was due to diking and draining. So when wetlands are dried out, they contract and they sink. After levees fall apart and tides return, the old marsh is now too deep for marsh plants to recolonize. More recently, Elkhorn's marshes have been declining due to drowning because of relative sea level rise. Both examples are visible in this image. As an estuarine research reserve, we care deeply about salt marsh, and we're committed to preserving and restoring salt marsh wherever we can, both for the plants themselves and for the animals that rely on those plants. Oh, and I am on not the right one. Here we go. You have to see the cute animals living in our salt marsh. In 2007, the reserve purchased a farm and its surrounding degraded salt marshes at a place we call Hester, shown in the red circle on this map. The uplands of that farm were used as a calla lily farm, and the surrounding former salt marsh had long ago been diked and drained for various uses. The levees on this property had broken by the 1980s, but the subsided soil prevented recruitment by salt marsh. The former marsh was replaced by an intertidal mudflat, like the one shown here, but this mudflat wasn't great habitat for the usual suite of invertebrates, so we thought Hester would be a great place to restore salt marsh. And we had a beautiful vision of how to do that. The Pajaro River, which you can see at the top of this image, needed flood control, and there was a dredging project to widen the river channel and to increase its flood capacity. So we worked with the Pajaro River project leads to take clean sediment from that project and to bring it to Hester to raise our marsh plain. And they did. They brought us sediment, but they didn't bring us as much as they said they would. For our project to build up 60 acres of former marsh, we needed 140,000 cubic yards of sediment, but we only got 50,000 cubic yards. We'd made commitments to get this project done, and we suddenly needed a lot of sediment. The flower farmer who had been on that property had left because the well was going brackish on our property. So we looked at that old fallow farm, and we decided to go for it. So our staff agreed to remove the top 3 feet of soil from the abandoned farm and move it into that mudflat to raise the elevation. Now, I had very conflicted feelings about this. It looked like strip mining to me, maybe robbing Peter, the uplands, to pay Paul, the salt marsh, right? But I also thought it might be a rare opportunity to restore grassland. Why? It turns out this had been done before on our land, but for exactly the opposite reason. In the 1970s, the previous landowners had scraped the uplands to create the fill to build those levees so they could dike and drain our marshes. They did this in a few places on land that's now the reserve, and including an area that was very close to our Hester project. The scraped areas created in the 1970s today host patches of native grasses and wildflowers that are uncommon in many of the other reserve grasslands. These photos are both taken from spots that were scraped in the 1970s. These areas support plants typical of native coastal grasslands like sky lupin, California oakgrass, purple needlegrass, Mariposa lily, and blue-eyed grass. It occurred to me that these harsh environments might be inhospitable to exotic weeds, sort of like serpentine soils, and it gave me hope that we might be able to restore these scraped areas to native grasslands. So, we used these previously scraped patches and other nice marsh-adjacent grasslands in the Elkhorn Slough area as reference sites. And with lots of help from our volunteers and the native plant nursery, Central Coast Wilds in Santa Cruz, we propagated tens of thousands of native grasses and flowers. And with our volunteers, we increased 150 pounds of native plant seeds to be planted on scraped soil. So we used increased farms on our property. So the upland scraping was completed in fall of 2018, and that area is shown off on the left-hand side there in an area that we call the Phase 1 grassland. It was about 5 acres. So we had those 5 acres of scraped soils ripped, disked, tilled, and then we set up irrigation. And then just a couple of months later in December, we planted that with about 18,000 native grasses and flowers. And we seeded other parts of those 5 acres with 90 pounds of native grass and flower seeds. The planting and seeding were done in large monoculture patches, which mimicked a lot of our reference sites. I'll tell you more about the species in just a minute. So things went pretty well in Phase 1, and we learned some lessons, so we expanded the project to restore more marsh and scrape more fallowed fields with that grassland shown in this yellow area here, a little bit smaller, about 3 acres of scraped upland. So here in Phase 2, earth moving was completed in fall of 2021, and then in December of 2021, we planted about 20,000 native plants, and we seeded with about 60 pounds of native seeds. So this time we did a combination of monoculture plots, and we added in some mixed species plots at this time. Okay, so can this approach work? The answer is absolutely. So in this picture, you can see in Phase 1, this was a seeded meadow barley plot. But did we build a weed-free prairie paradise? No, we didn't. Our big 7 weeds, both in Phase 1 and Phase 2, have been non-native fescues. A lot of that's rat-tail fescue. We have some rabbit's foot grass, non-native bromes. You can imagine that's a lot of that is ripgut. We have bristly oxtongue, horseweeds, both a native one and a non-native. 2 species of the melon lotus, the white and yellow clovers. We get quite a bit of burr clover out there too. So we found that weed success can be partly explained by the soil. So what you're looking at here is a cross-section from one of the Phase 1 scraped area. And no surprise, we dug through different soil and subsoil horizons. So on the top, you can see the grasses, and right below that is the dark brown topsoil from the farms. And then below that are various strata of sands, clays, and some really red sediment there at the bottom. So when we were doing our planting and our seeding, we were really mostly working in these deeper white and red sediments, but sometimes topsoil was left behind or incorporated in as the machinery went through. And we found that topsoil left behind favored exotic plants over natives. So we do weed control in the Hester grassland, and it works best in the white and red soils, and it doesn't work nearly as well in those brown soils. So here's what we do. Especially in the first couple of years, we used some limited mowing, both with a tractor and weed whackers, like you see here. Consistently from the beginning till today, we've been doing hand pulling, mostly where we've either planted broadleaf plants or where the weeds come out very easily by hand. We've done some limited salting, especially to take care of weeds that are growing right along that transition between the grassland and the salt marsh right below it. We've continuously done spot spraying, exclusively for broadleaf weeds, using broadleaf specific herbicides like triclopyr. And now that we know that these brown topsoils can be very, very weedy, when we go in and plant or seed, we put in very aggressive native plants, particularly gumweed or other similar plants in those patches to outcompete the weeds before they become a problem. So how are the weeds doing? Let's take a look at just the grasses and just in the Phase 1 area because that's oldest. So I've got year along the bottom, percent covers on the side, and percent covers measured by point intercepts taken along transects. We measured across 8 different planting plots. These are those monoculture plots, right? So we have standard error shown on these lines. So we skipped data collection in 2022. So rabbit's foot grass and ripcut brome, which are shown in yellow and green lines, are bopping along at around 10% of our points. That's not too alarming. They aren't shown here, but the clovers and weedy asters that I mentioned a couple of slides ago are following a similar trend. We had some initial bursts by those species, but then they've declined mostly, and they're kind of bopping around 10 or 20% of the cover. But on the other hand, exotic fescues, like I mentioned before, largely rat-tail fescue, seems to be increasing over time. And looking at this chart, it looks like it's taken over all our plots, but our point intercept monitoring records how many points include a species. But a point might hit 2 or 3 species, so our total cover could be 200 or even 300% for a transect. But this graph certainly suggests that almost all the points that we have hit in the phase 1 area have at least an understory of non-native fescues. So we see that at our best reference sites too, if that's any consolation. But we do think, despite kind of this impressive cover of fescue, that we might have something that's sustainable going on. Why? Because if you look at the big picture, we've gotten a lot of native plant growth too. I'm going to show you a series of before and after images without much comment right now, and then we'll dig into a couple more graphs. So what you're looking at here is in 2018, that phase 1 area, the California Conservation Corps here is planting creeping wild rye, and that's what that same site looks like today. Now let's move over to the phase 2 area. We've got the CCC's planting some blue-eyed grass. And here's what that area looks like, at least in the spring now. Here's an area with a lot of brown topsoil where we had seeded gum plant seed, and here we are harrowing that in. And this is what it looks like today, at least in the late summer. Lots of gum plant out there. And finally, here's one of our volunteers hand-seeding stipa, a purple needlegrass with a mix of flowers. And in the spring, that's what that same area looks like today. So we're pretty proud of ourselves. I do want to share a few more lessons learned from our monitoring. One of the first things is that we were really surprised that our hand seeding did much better than the tractor seeding that we attempted in the phase 1 area. So this is just from phase 1, and I've got hand-seeded species on the left, tractor-seeded species on the right, and this is just for the first 2 years. We're not too sure what happened. These aren't replicated experiments, so there are no error bars here. So it's hard to say if the problem that you see on this right-hand side with the tractor-seeded bromus and elamis was due to the tractor seeding as the method, the species, or the location of these plots. Nonetheless, we have not used tractor broadcast seeding. Again, we're doing it all by hand or using belly seeders. And we haven't used California brome or blue wild rye again. Those species weren't actually found in our reference sites. They came from literature reviews that suggested they were good native grasses to use for cover crops. So that brings me to my next lesson learned. Reference site data really do matter. And in the next graph, I'll argue that rhizomes seem to be very helpful for longer-term sustainability in these projects. So here are the species, the native plants that we planted that I promised a few slides ago. This is phase 1 only, and we missed monitoring again in 2022. On the bottom are the species and the planting method. Excuse me. On the side is percent cover, again, from point intercepts, no replication. And so with the years, we start off with the earlier years in light, and then the most recent year, 2024, is in the very dark green. So the red dotted line is our generalized target cover based on what we find at our reference sites. That tends to be about 30% cover of native species. And most of our species, you can see, are meeting our objectives 5 years after planting, except California brome, which has gone missing, even though this one was hand-seeded, not tractor seeding. As you can see, okay, and then I wanted to point out that hand seeding took off fast, as you can see on the right side of the graph, but then declined. Plants with rhizomes, like the saltgrass, the creeping wild rye, and the Mexican rush, have generally been increasing over time, and so those are shown in the red circles here. For phase 2, we dropped the California brome and decided to try out a few more grassland species from nearby reference sites. Here we added more flowers and California oatgrass. We're only about 2.5 or 3 years in, but mostly we like these numbers and trends that we see here. We think that this reflects our lessons learned from phase 1. But one lesson that's taken me a while to learn is that meadow barley is really picky about where you plant it, especially the seeded one, the one that's closest to the right, almost closest to the right here, which leads me to my final lessons learned. In grassland restoration, at least along the coast, things change. Despite very high cover of meadow barley across plots in the early years, this grass does eventually retreat to its favorite patches. So you can see what that first one I had shown you when I told you absolutely it works. This year, this is what it looks like. So it's much patchier. We're much closer to 30% cover, not 100% cover there. So it kind of finds where it wants to be. But the nice thing about meadow barley is it also expands out beyond our original planting area, and it finds nice places outside of that. So we really like that. And our first foray into annual flowers has been interesting. The first year that we planted the poppies and the lupins, we just had this spectacular super bloom. But maybe due to heavy seed predation, which might be from the ground squirrels, we're not sure what's going on, or maybe it's competition from the seeded needlegrass that we put in there too. But our poppies and lupins have really settled into much sparser coverage as of this year. So having a multiple year perspective and lots of lessons learned is good because we've committed to one more phase, and it is daunting. Phase 3 is in progress right now, and it's adjacent to phase 1 and 2, but it's bigger. And this scraped soil is raising a vulnerable marsh that's a little closer to the estuary's mouth. So this is just a sliver of what phase 3 looked like a couple of months ago. If I haven't conveyed some of my ambivalence about this project during the talk, let me acknowledge it now. I would not have designed a marsh and grassland restoration project this way. It feels extreme with these deeply removed soils, and I think only time is going to tell if this grassland will be sustainable over the long term. I'm certainly not advocating that you go out and strip mine other areas to form the foundation of prairie restoration, but I wanted to share this story as hope in case you're ever faced with a large disturbed area like this. If you are, do your homework, test things out, and then do what seems best based on reference sites and trials. And finally, find great people to work with. I hope these slides have shown that it takes a village to get this far, and we are thankful to everyone, including our funders, who have helped along the way. It has been hard work, but fun and often inspiring too. So this is just from the last couple of months in phase 3, and there are my stipends starting to come up in phase 3. All right, thank you. Seeing some here.
Yeah, I'm not surprised that the Bromus carinatus and Elamus glaucus didn't do well. It tends to like shady areas. But my question for you is, have you considered using some native annual grass to fill that niche that's being filled in by the rat-tailed fescue?
No, apparently we do have a native annual fescue. I've never come across it. It's recorded. We see it on CalFlora, but I haven't come across it. So we haven't even been able to collect it. And we have been doing everything locally. So it's a good idea. We have certainly tried other species as well. Not everything likes this. So a lot of things that we've tried, mostly perennials though, a few things have failed.
Yeah. Well, first of all, the meadow barley, in the mid-2000s or early 2000s, I worked at River Partners, and there was similar pickiness about, site pickiness with the meadow barley getting established. But my question about outreach possibilities, I'm curious, did any of the students at Ohlone Elementary have any opportunity to interact with this restoration, or is it like too over their head?
A lot of other programs. We do a lot of outreach with a lot of our different programs. There's both the Elkhorn Slough Foundation, and they work a lot with younger kids on other projects that are happening on the Elkhorn Slough Foundation, and then we also bring a lot of kids out for other projects. The school kids I've been working with the most here are, it's an alternative high school group. It's called Mountains to Sea. It's kind of outdoor recreation. They come out several weeks a year. So I've mostly been working with high school kids on this one.
How about any field trips from the Monterey Bay Aquarium?
We've not. That'd be a great idea.
Okay, thanks.
Cool project, thank you. What are you doing with the soil that you're removing in phase 3? Because we're finding it can be hard to find takers of soils that you remove from sites like this.
Oh, okay. The only reason we're taking the soil is because it went straight from there, straight into the degraded salt marsh on the adjacent property. So let me see if I can find going through this. Yeah, here we go. So for phase 3, the soil came out of this purple area, and then see where the eucalyptus are there? It went into that really low marsh up there. So it all got moved by all that equipment, and it's raising the marsh up there. Anybody else?
You mentioned that you don't recommend strip mining in order to create a foundation for coastal prairie, but I am curious how you think these techniques might work as you go up higher in the marine terraces.
That's a good question. I would say if this place looks amazing in 20 years, then maybe I would recommend strip mining. I'm just really, I feel like it's too preliminary right now. I feel like it's still experimental. Yeah, I don't know what would happen if you would keep moving up, and I don't know if other people have been trying that or not.
How might you duplicate some of the things that you get the advantage of without doing the strip mining?
So one thing that my colleague at the Elkhorn Slough Foundation is going to try to do is we've been taking eucalyptus down, we've been creating biochar out of that, and he's going to experimentally try putting biochar in without compost in some of his grassland areas to see if maybe that can kind of suck up some of the nutrients instead of freeing it up, kind of sucking it up to create these low nutrient conditions. So maybe that's a way forward if we don't want to bring in the bulldozers. He's going to give that a try this year, and we'll see how it goes.
Okay.
All right.
Time.
Thank
you
you.
very much, Andrea.